All right, this is part 2 to section 4.5, and like I said in the previous video, you're going to only get good at this using examples after examples. And so I'm going to do these 6 examples in this video, and then do some more examples in the following videos. And again, we're using U-Substitution, and the general idea is to substitute U in for some part of the integral so that it makes it easier to integrate. And when you do this variable change, you have to substitute something in for dx as well. So whatever you use for u, you got to take the derivative, and then whatever the derivative is, you want it to be so that it's plugged into the integral for something involving dx. So for number 9, and I think I'll just go ahead and just do the problem and then explain why I'm doing that substitution. It's 1 plus 6x to the 4th. And then they had parentheses 6 and then dx. So what I could substitute for u, now to me right away it looks like, well, with the 1 plus 6x, that seems to be the logical option to use for u. It's the more complicated stuff, I guess, you would use for u. So if I let u be 1 plus 6x, all right, so then I got u to the 4th. Now I need to substitute something in for 6 dx. Well, taking the derivative, knowing that u is 1 plus 6x, that means du. And then you take the derivative of 1 plus 6x. Well, derivative of 1 is 0 because that's a constant. And then, so I guess I'll go ahead and write it out. So that'll be 0 plus 6 times 1, which is 6. And like in the previous video, we're going to attach a dx when on the right side for our derivative involving x. Okay, and if I worked it out how we've done it in the past, we would let u be 1 plus 6x, take the derivative, that would give us u prime, which we know is 0 plus 6 times 1, which is 6, so u prime is 6. But u prime is really du dx. And we can rewrite this by bringing the dx over to the right side. So it'll be du is equal to 6 dx. All right, that's what we've done in the past. I'm not going to work it out like that in the other examples, but that's where I get the du on one side and the dx on the other. So that way I can substitute du in for that 6 dx. All right, so substituting what we have, so the 1 plus 6x, that's u. So now I just have u to the 4th, and then the 6 dx, well, that's du. All right, now we know how to integrate this. We just add 1 to the exponent, so it'll be 4 plus 1, and then you divide by that same thing, so 1 over 4 plus 1, and then attach our constant of integration. So we get 1/5 u to the 5th. And then we need to back substitute what u was. Well, u was 1 plus 6x. So we get 1/5 times, and I'll put it in parentheses, the 1 plus 6x. That whole thing is being raised to the 5th power, and then plus c. All right, and that's going to be our answer. Again, I chose u to be the more complicated thing of 1 plus 6x, so that when I take its derivative of 1 plus 6x is 6, and I have 6 in the integral. And that way I can substitute in the derivative in for 6 dx. And that gave me u to the 4th du, because 1 plus 6x is u. 6 dx we found was du, so that's why I substitute those in, and it only involves u. Then I integrate using the rules that we already know. And you've got to make sure to back substitute at the end. All right, so that's number 9. Number 11. Now notice I have negative 2x in the parentheses. Well, I know the derivative of x squared is 2x, and so I could try to let u be this whole thing, 25 minus x squared. I want, just to make it easier, to include the 25. Since the derivative of a constant is 0, the 25 is going to go away when you take the derivative. So I'm going to let u be the whole thing, 25 minus x squared. So take the derivative, and now I'm just going to write it as du, and then equals the derivative of 25, that's a constant, that's 0. And then derivative of x squared, that's going to be minus 2x to the 2 minus 1, which is just minus 2x. All right, and then I'll attach the dx to it. So really I have du is negative 2x dx. All right, so this whole thing is du, and then the 25 minus x squared is u. So that changes the problem. So the square root, and then 25 minus x squared, that's u. So it's really the square root of u. And then the negative 2x dx, that whole thing is du. And now I can integrate this, because I can write the square root as to the 1/2. So this is u to the 1/2. And then integrate. So it's going to be u to the 1/2 plus 1. And then you divide by that same thing. And then plus c is the constant of integration. So 1/2 plus 1, that's 3/2. So I have u to the 3/2. And we're dividing by 3/2. And that's the same as multiplying by the reciprocal. Reciprocal of 3/2 is 2/3. So I'm going to go ahead and erase this and then put 2/3 in front. All right, so we're almost there. We just got to back substitute what u was. Well, u was 25 minus x squared. So this is 2/3 times parentheses 25 minus x squared raised to the 3/2, and then plus c. All right, so I let u be the entire thing, 25 minus x squared, rather than just u being minus x squared, because I still have to worry about the 25 somehow. So if I let u be the entire thing, because the derivative of 25 is 0, it goes away. So its derivative is still the same. It's still negative 2x. if I were to use just x squared or 25 minus x squared. So I use the more complicated version. All right, so 13 is x cubed times parentheses, and then it's x to the fourth plus 3, and then squared dx. And again, ideally, you would want to use some more complicated stuff for you. So that when you take its derivative, you can substitute it in for something involving dx. All right, so looking at what we have x cubed and then the times x to the fourth plus 3. That's in the parentheses. If you notice, there's a pattern here. I've been choosing u to be whatever's inside of some particular operation, whether it's a square root or raising something to an exponent like to the fourth power. I let u be what's in the parentheses. That was more complicated stuff. So the more complicated stuff I would say is x to the fourth plus 3. So if I let u be x to the fourth plus 3, taking the derivative, what's the derivative of x to the 4? That's 4x to the 4 minus 1, which is 4x cubed. And then the 3 goes away because that's a constant. So I have 4x cubed, and then I attach the dx. Now notice I have an x cubed and a dx. So that lines up. But here, du is equal to 4. I don't have this 4. We want to do something with this 4. Well, if I multiply both sides by a fourth, so that's going to give me 1/4 du. And then a 1/4 times 4x cubed dx. So the 1/4 and 4 divide out, they cancel each other out, so you just have the x cubed dx. So I have 1/4 du is equal to the x cubed dx. And the x cubed dx is what we have in the integral. And it might help to write it out as follows. It might help to just write it so that you have the x to the 4 plus 3 squared listed first. And then put x cubed dx. So it's more obvious as far as what you're using for u and du. And we're saying that's u. And what was x cubed dx? Well, we had to rewrite it so that we could get x cubed dx to be 1/4 du. So this is what I'm using for the x cubed dx. So I'll substitute everything in. So you have u squared times 1/4 du. All right, so just to recap, I let u be the more complicated stuff, which was the x to the 4th plus 3. Taking the derivative, you get du is equal to 4x cubed dx. Now the thing is, I have in the integral, I have x cubed and dx. So I want to substitute it in for x cubed dx. But when I took the derivative, I got this 4x cubed dx. But I essentially divide both sides by 4 or multiply by a 4th. So that brings the 1/4 over to the left side with du. And on the right side just is x cubed dx. That's what we wanted to substitute in for. So that's why it's in this case 1/4 du instead of just saying it's du for x cubed dx. All right, so integrating this, I could factor out 1/4 and then focus on integrating u squared. So then that's going to be u to the 2 plus 1, and then divided by the same thing, 2 plus 1, and then plus c. So we have 1/4 times u cubed divided by 3. Well, that's u cubed over 12. And then I just back substitute what u was. And we had u was that whole thing, x to the 4th plus 3. So we're going to put parentheses and then x to the 4th and plus 3, all of that to the 3rd power. And then this is divided by 12 and then plus c. And that's going to be the answer. All right, so the next one's number 13. Or sorry, I did 13, next one's number 15. All right, so that's the problem. We have x squared, and then we have the 2x cubed minus 1, all of that raised to the 4th power. Well, the more complicated stuff is the 2x cubed minus 1. All right, that's the stuff that's in the parentheses, but I'm raising to some particular exponent. So the general, I guess, pattern recognition here is that, like here, I let u be the x to the 4 plus 3. That was what was in parentheses there, and it involved an exponent. You see how I wrote it as x to the 4 plus 3 squared times x cubed dx? I'm going to rewrite the problem so in a similar fashion. So I'm going to rewrite it. So I have the 2x cubed minus 1 to the 4th, and then times x squared dx. All right, because multiplication is commutative, I can switch the order around. All right, so that way, to me, it's more, maybe a little bit more obvious. I'm going to let this portion be u, and essentially I want to find some kind of derivative so that this will involve substituted in, so it would involve du. So I said involve du somehow. So if I let u be 2x cubed minus 1, take the derivative. So I have du equal to, and taking the derivative of 2x cubed, so I'll do 2 times the derivative of x cubed. Well, the derivative of x cubed, that you drop the exponent down, will be 3x to the 3 minus 1, which is 3x squared. And then minus 1's a constant, so that derivative is 0. So I just ignore that. So I have, and then now I'm going to attach my dx, since on the right side I have everything involving x. So du equal to 6x squared dx. Now notice in the problem, I have x squared dx. So I need to rewrite this so that it only has x squared dx. So I would multiply by 1/6 to get rid of the 6. All right, so if I multiply both sides by 1/6, on the left side you just get 1/6 du. 6 times the 6, that those pretty much cancel each other out to be 1. So you have basically 1x squared dx, which is just x squared dx. So the 6 goes away if I multiply both sides by 1/6. All right, now I have it just being x squared dx. So now I can substitute this in, and then I'm substituting just u in for that, 2x cubed minus 1. So where it says involve du somehow, well, the way it's involving du is that it's going to be 1/6 du. So I have now, instead of 2x cubed minus 1/4, I'm going to save time by not switching colors so often. I'm going to go ahead and just write it in blue, u⁴. And then x squared dx is now 1/6 du. All right, so for integrating this, I would factor out the 1/6 and focus on integrating u⁴. And we know we just add 1 to the exponent. So I'm going to have 1/6 times, and it's u⁴ plus 1 divided by 4 plus 1, and then plus the constant of integration. So I have 1/6 times u⁵ over 5, but 6 times 5 is 30. So I have u⁵ over 30, because 6 times 5. All right, now I just back substitute what u was. And I let u be 2x cubed minus 1. So I'm going to have in parentheses the 2x cubed minus 1. All of that to the 5th power, dividing it by 30, and then plus c. All right, and again, at this stage, I'm assuming you already know the derivative rules and know the basic integration rules. All right, so that's going to be the answer. The next one's number 17, and let's go back up to the top. So I have 17 and 19 I'm going to do now. And then I'll stop the video and continue on another video. Hopefully now it's making a little bit more sense as far as what's going on here. The more examples, again, I think the better. So this example is t times the square root of t squared plus 2, and then dt. Well, I'm going to let you be the more complicated stuff. The more complicated stuff is the t squared plus 2. That's underneath the square root. So what I'm going to first do is rewrite it so that you have the square root of t squared plus 2 listed first, and then write the t times t dt. So the t squared plus 2, that's what I'm going to let u be. The t dt, I want to substitute something involving du. To somehow involve du. So u is the t squared plus 2. Taking the derivative, get du is equal to derivative of t squared, that becomes 2t. And 2 goes away because that's a constant. So it's really 2t plus 0, but that's 2t. And then remember to attach dt so that I have only stuff involving t on the right side. All right, now I have t dt in the integral. In this case, down here in yellow, I have 2t dt. So I'm going to multiply both sides by a half. I need to multiply by 1/2 to get rid of the 2. I have 1/2 du. And then I do 1/2 times 2, those go away, so I have that's going to be equal to t dt. All right, now this 1/2 du is what I'm going to be plugging in for t dt. All right, so that's what I'm plugging in for that. All right, so now I'm going to rewrite the problem involving just do my variable change. So for the variable change, it's going to be the integral of square root of u, and then times, instead of t dt, that's 1/2 du. All right, now for integrating this, I'm going to factor out the 1/2 in front. So it's 1/2 times the integral. And then integrating square root of u, I write that as u to the 1/2. And then du, so now I'm going to integrate. So that's 1/2 times, and you do u to the 1/2 plus 1, divided by that same thing, 1/2 plus 1. 1/2 plus 1 is 3/2, so this is going to give me 1/2 times, and so I have u to the 3/2 divided by 3/2. Dividing by 3/2 is the same as multiplying by 2/3, so I'm going to go ahead and just write it as times 2/3. Okay, so I went ahead and changed it to the reciprocal of 3/2. All right, so now I just multiply 1 by 2 to get 2. So I get 2, and then 2/6. Well, you could divide out the 2's, right? So these divide out, so you just get 1/3. All right, now back substitute what u was. And u was t squared plus 2. So this is going to equal 1/3 parentheses t squared plus 2, and then to the 3/2, and then plus c. I know I'm kind of switching how I'm writing it. Like previous example, I would have written it like as t squared plus 2 to the 3 halves, and then all of that's divided by 3 plus c. It's the same thing. I just sometimes will like to just put the fraction in front. So I just pretty much interchange between these two. Most of the time, I think I'm just going to go with the first case where I put out the 1/3 in front. It's a preference thing. All right, this number 19 is going to be the last example I do for this video. So it's the integral of 5x times the cube root of 1 minus x squared, or the cube root of 1 minus x squared dx. All right, so the cube root, the stuff underneath the sign, the cube root sign, the 1 minus x squared, that's what I'm going to let be u. And so I'm going to rewrite the integral. So I will have that listed first. And the 5 is a constant. So I could just go ahead and bring the constant in front of the integral. So I have 5 times the integral. And now I'll put the cube root of 1 minus x squared. And then x dx. So that way, to me, it's a little bit more obvious what's going to be u and what's going to be something involving du. Okay, so that's what u is going to be. This is going to somehow involve du. All right, so u is going to be 1 minus x squared. So du, that's taking the derivative. Derivative of 1 is 0, so that goes away. And then minus, and then x squared, derivative of x squared is 2x. So this becomes minus 2x, and then attach my dx. So it has, I can substitute it in for the dx portion in the integral. Now notice I have just x dx, and here I have negative 2x dx. So I'm going to get rid of the negative 2 by multiplying both sides by negative 1/2. So on the left side, you get negative 1/2 du. And then the negative 2 goes away on the right side, so you just get x dx. All right, now I can substitute the negative 1/2 du, that's my somehow involving du, all of that in for x dx. So changing the variable, I'm going to have 5 times the integral and the cube root of u, and then instead of x dx, that's negative 1/2 du. I can factor out the negative 1/2 in front of the integral, but I already have 5 there, so I do 5 times negative 1/2. That's negative 5 halves. So I have negative 5 halves, and then the integral of cube root of u du. Well, the cube root is the same thing as raising it to the 1/3. So I have u to the 1/3 du. All right, so now I integrate, so I have negative 5 halves, and then times, and then you use the regular power rule of integration for u to the 1/3. So it's going to be u to the 1/3 plus 1, and then dividing by that same thing, 1/3 plus 1. That's going to give me negative 5 halves times, well, u to the 1/3 plus 1, that's going to be u to the 4/3. And if I divide by 4/3, that's the same thing as multiplying by 3/4. So I'm going to go ahead and write it as 3/4. And now I multiply, so negative 5 times 3, negative 15, and then 2 times 4 is 8. So I have negative 15/8. u to the 4/3 plus c. And now I just back substitute what u was. U was 1 minus x squared. So I'm going to have negative 15/8 times 1 minus x squared to the 4/3 plus c. All right, so that's where I'll stop it for this video. And again, more examples, the better you'll get. I did 6 examples, so now hopefully it makes more sense what I'm choosing to be u. All right, and that's it for this video.